Hi, okay, welcome to another exam collection that's been dedicated to paper one of the 2020 exam. Obviously, this will be good no matter what year you do it in, but we've got that advance notice, so this is really, really relevant stuff. Okay, it's a case of hit and pause, press and play. We've got 6 to do together, so hit pause and press play when you've had a go at that one. Okay, so our keywords here that we should be picking out are things like speed. We've got some distance going on. We have time. It's all in the question. So the first thing I should be doing is getting that triangle in because I'm going to need it. Okay, we're being asked to work out the average speed. So that is distance over time. We've got 15 miles as our distance over 6 as our time, and that's 6 hours. Now, speed is going to be given in miles per hour. So we need to get that cancelled. So let's divide through by 3 because that will go really nicely, giving me 5 miles in 2 hours. And then I'm just going to half that to give me 2.5 in 1 hour. So in miles per hour, it's 2.5 miles per hour. We're then being asked to see if Sunita is right with her claim that Peter walked over 20 kilometers. So we use boxes and labels. So we've got our fact. 5 miles is 8 kilometers, fact. The other fact in the story is that he walked 15 miles. So that is going to go into our miles column. And then you can see that side needs to be times by 3. Do the same that side. 8 times 3 is 24. Did he walk more than 20? Yes. Make sure you answer the question. Yes. I'd even go for a full-on sentence and say, yes, he walked 24. All right, next question. Now, this one does say on the grid draw, but obviously we're on a computer, so you don't have the grid. Now, feel free to just sketch a kind of freehand of how you think that will look, or take the time to pull together an accurate graph, but complete the table and press play when you're ready. Okay, so we've been told that y is equal to x to the power of 2 minus 4x minus 2. So these y values are being generated from putting these x values into the rule that we've been given. So the rule, x squared minus 4x minus 2. I'm going to put x equals 3 in, which is going to give me 3 squared minus 4 times 3 minus 2. Just get it all written down so you can see clearly what it is you need to do. 3 squared is 9. Now I'm just going to box off the bits that I do so that I know what I've got left. 4 3s are 12, but I've got a minus I've not used yet, and then I've got that minus 2 there. 9 take 12 take 2 is equal to minus 5. So minus 5 would go into the table there. I've now got x equaling 2 going in. So I've got 2 squared minus 4 times 2 minus 2. I'm going to concentrate on it in the same way. And then 4 take 8 take 2 is equal to minus 6. So minus 6 will go in. And then it's really worth looking at whether a pattern is starting to appear. This has gone 3 minus 2 minus 5 minus 6. Now it's starting to go back up, and it's going back up the same. It's going minus 5 and minus 5, minus 2, minus 2. So I'm not going to do all this work. I don't need to, because I can see from the pattern that that has got to be 3. And that's the table completed. What you would do is you would take those and you would plot them as coordinates. So that is coordinate 5, 3. That is coordinate 4, minus 2, etc., etc. And that is what you would end up with. Okay, so you plot and you must draw through your coordinates. The number of times I see just the plots plotted, no line. Also make sure it's never straight. Don't go, it's got to be this smooth curve. It doesn't matter if it wobbles a bit. I could have gone for perfection, but I really wanted to show you that's an acceptable graph. It's going through the points as closely as I can. It's a bit of a wobble. They're not going to worry about that whatsoever. Now, they could ask a second part to this question, which I really want to just throw in there. I've just thought about it now. And that is to provide an estimate for the solution of the graph. Now, if you were asked to estimate the solution, you would be looking at where it crosses. I'm not sure that's coming out very well. Let's do that. Where it crosses here and where it crosses here. Those 2 points would be your estimate. So if I just move those out the way now and put on across here, then it will say estimate. You'll do your best. That looks like 4.5. So X is equal to 4.5. And here, again, it looks like it's crossing at minus 0.5, minus 0.5. Okay. Next question. Hit pause, press play when you're ready. Okay, so you're really, really clearly being told that you're not to do the exact calculation. So there's no point. It's not going to get you any marks. They just want to know why he cannot possibly be right. So they're really just testing how confident you are with the method. And he can't be right because his denominators aren't the same. He's literally done 3 plus 8 is 11. So something worded along those lines about the denominators needing to be the same is all that you would need for the mark on a question like that. And that's the next one. Hit pause, press play when you're ready. So I've got some useful keywords as I read through this particular question. I can see that I have density and I have mass in that question. So I am going to be making my mass density volume triangle before I do anything else. Okay, it says I've got to work out the mass. Now to find the mass, I have to do the density times by the volume. When I read the question, I have the density. I have 8, but I don't have the volume. And this is quite common. So what I actually need to do is get the volume. When I go back and look at my diagram, it doesn't look like a 3D shape. So they've been quite mean with this question. It is a 3D shape because they've told you it's a solid prism and that we're just looking at the cross section. So we're kind of looking at that front face only. They said the length of the prism is 2 meters. So actually, sorry, yeah, let me just do that. So that is actually our solid. And like I say, they've said that the length is 2 meters, which is a completely different unit to the rest of the cross section, which has been given to us in centimeters. So we really need to decide whether we're going to go meters or centimeters, or do we even have a choice? So this is where we keep going back and we keep reading that question and checking in with details. Okay, the density of the metal is 8 grams per centimeters cubed. If density has used centimeters, then we have to use centimeters, which means that has to change. So what I've actually got here is 200 centimeters. Okay, so I have to try and find the volume because without it, I'm really not getting very far at all. Yeah, that's what's missing. That's what I've got to find out. So area of the front face times by the third length. Now the front face is just another way of saying cross section. It's the language we use in school. So if you've not heard that, that will be why. But it's just the cross section. So I have an L shape to work on. So I'm going to, first of all, work just on that section there, which I can see is 7 times 2. So I've got 7 times 2, which is 14. And then I can look at the other bit, which is just that bit there, which is not a full 7. Okay, so I've got to be paying attention. The full 7 stretches along. I only want that bit, which means taking 2 off of here. I'll give me 5. So I'm going to be doing 5 times 2, which is 10. Add that together, and the area of my front face is 24. Okay, now I'm timesing that through by the third length. The third length is the length that gives it a third dimension, which is this length here. So that is our third length, the length that makes or gives the prism its third dimension. So we're going to be timesing that through by 200. So we can just double the 24 to get me 48 and add those 2 zeros. So I've got 4,800 as my volume. Okay, last thing to do is to multiply through by the 8. So we're now actually working out that mass, all right? So I'm going to just ignore those 2 zeros because obviously I haven't got a calculator. I can't just throw it in. So I'm going to do 40 times 8, which is 320. I'm going to do 8 times 8, which is 64. I'm going to add those together, which is 384, and then add those 2 zeros that I ignored from over here, get those added back in, and that is grams. If they'd made a point about saying, give your answer in kilograms, then we would have divided through by 1,000, and it would have been 38.4 kilograms. But they haven't, so we can leave it there, and that is the answer to that question. All right, next question. Hit pause, press play when you're ready. All right, so what we want to do here is get these into ordinary numbers. If they're in ordinary numbers, we can read them easily, and then we can put them into the order starting with that smallest first. So this is times by 10 to the power of 2 times by 100. So I'm going to move that 2 places, and I have got 3.8 as my ordinary number. This one is raised to the power of -4. So it's a small number. I need to move 1, 2, 3, 4. That's going to give me 0.38. Don't need to add in the other zeros. If you did, it doesn't matter. Just don't need to. Obviously, that is an ordinary number, so I don't need to do anything with that. And this is times by 10 to the power of -1. So again, I'm moving it to make it smaller by 1. So that will give me 0.038. And then I can see just by looking at them that that's the smallest. That would be the next one. That would be the next one, with this being the last. And then when it comes to rewriting them, you write them using what they gave you in the first place, okay? Which is why I kind of numbered it through, because it just feels easier. So what's next? And then 0.038 times 10 to the 2, and then 380. Okay, hopefully that went well. So last one, this is our 6th question. We tend to just do the 6. So this is a reflection. Again, a little bit harder to do when it's on screen, but important that we look at it and see it before the exams. So hit pause, have a go, press play when you're ready. Okay, so with this question, we're being asked to reflect in the y-axis. So it's just really, really important that we recognize that the y-axis is the one labeled with the y, so here. And then that becomes like a mirror line. It's like a line of symmetry almost, so that my reflection will be flipped over that line and it will be the same distance between it. You can use tracing paper for this. That works really, really well. This is the solution. I pre-did it. so that you can see it nice and easily. And the only other thing I really wanted to mention was you could be asked the y-axis or the x-axis, but you could equally be asked things like y equals -1. So you need to know where that line is. So the line y equals -1 is again on that y-axis. This time it's where that -1 is. So it would have been reflecting through that line there. And then that line is wherever they tell me to put it. You know, if it's reflecting y equals 3, it'd be drawn there. Y equals -2, it would be drawn there. And if you had an x equals, then it's doing the same thing. It's just going to be a vertical line cutting through whatever number on the x-axis they ask for. All right, hopefully that has been a helpful selection of exam questions. It's been useful. I'm going to be making plenty more ahead of the exam itself, which is obviously depending on when you're watching this, it's coming up super fast. So good luck with your revision. Keep checking in with these videos. Hit subscribe if you're finding them useful. As soon as paper 1 is done, the videos for paper 2 are going to come up as well. All right, thanks for watching this Target Maths video.